Hi, I'm Yildirim, and today I'll be presenting our paper, Sketching AI Concepts with Capabilities and Examples, AI Innovation in the Intensive Care Unit. Advances in artificial intelligence have enabled unprecedented capabilities, yet innovation teams really struggle when envisioning AI concepts. Today, the majority of AI products fail before deployment due to selecting and working on the wrong problem. And current literature on human-centered AI often captures how to design and prototype AI interactions to get the design right, but little research details early phase ideation and problem formulation, the work we do to discover what is the right thing to design with AI. One challenge is the knowledge gap between disciplines, so data scientists find it really difficult to elicit what domain stakeholders need. And without that insight, they tend to envision AI systems that users don't want. Domain experts, on the other hand, struggle to understand what AI can do, and they tend to ask for AI systems that can be built. Recent work suggested that HCI could play a key role in bridging this gap by facilitating early phase ideation and problem formulation between data scientists and domain experts, particularly through the use of AI capabilities and examples. In this work, we build on our prior research to explore facilitating interdisciplinary AI innovation in the context of healthcare. Our interdisciplinary team involved clinicians, data scientists, healthcare professionals, and HCI researchers. We had access to a rich dataset coming from 39 intensive care units across 18 hospitals. So if you're familiar with MIMIC, it was pretty similar. We had patient-level variables such as patient demographics, what medications they were on, orders, labs, etc., as well as some metadata on the primary care team. We engaged in an iterative design process to broadly explore AI use cases in the intensive care that are buildable and useful. We conducted a 3-phase study, starting with brainstorming, followed by problem formulation, and then co-design. We conducted design workshops in each phase, which were recorded, transcribed, and analyzed using affinity diagramming. In the first phase, we conducted brainstorming workshops within our team, so the healthcare team members would bring their expertise in what's clinically relevant and useful. The data science and AI team members would lean in on what is buildable with the data we have, and the HCI team members would bring their expertise in ideation. We conducted 2 workshops. The first workshop followed a traditional user-centered design approach. So starting with users, we asked clinicians, what are your pain points? Where do you want AI to help? And at the end of the brainstorm, we mapped the outputs onto an impact effort matrix to assess their quality. And we realized that we had mostly produced ideas that were super hard to implement, and only about half of them were valuable. So most of the ideas were around clinical decision-making and documentation, and the breadth of the concepts were somewhat limited. So the workshop was successful in getting everyone to ideate together, but the quality of ideas wasn't really there. In the second workshop, we decided to shift things a little bit. So instead of starting with what clinicians need, we started with a review of AI capabilities and examples that use moderate AI performance. So we had 8 capabilities and examples that we selected from our AI brainstorming kit, and we did a quick review before the brainstorm, going over each example. And we also had these as printouts posted on the wall. So we said, okay, here's something AI can do. Can you think of a place where this could be useful for you? So almost like priming the brainstorm. For instance, talking about spam filter, it looks at your email, is this spam or not spam? We asked our team, can you think of situations where classifying things as urgent or not urgent, or important or not important would be useful? Using this approach, we actually started to produce concepts that are on the upper left quadrant, so concepts that are low effort and high impact. For example, we talked about demand prediction, like Amazon's anticipatory shipping, and how this might apply to intensive care. And doctors and nurses thought, oh, can we look at a bunch of patients in the ICU and predict what medications would be needed tomorrow to reduce time to medication from the pharmacy? So instead of only focusing on things like clinical decision making, we moved towards concepts that help with coordination, planning of resources, workload management, and patient prioritization. In addition, we changed where the concepts fall in the problem solution space. So in traditional brainstorming, we were very much getting things in the upper right-hand corner, so post-it notes that are in yellow. These are very difficult problems where you need excellent model performance to be valuable. And then we really shifted down to a space looking at much simpler problems where moderate model performance is beginning to be acceptable. So moving from ideation to problem formulation, we wanted to detail the concepts to capture the data resources as well as the human-AI interaction. So we selected and detailed 12 concepts. These were things like anticipatory pre-ordering of medications or identifying sick or busy patients for workload management. Before the workshop session, we created a worksheet that captured what action the system performs, what the AI system reasons about, and what the system knows. We call this the Do, Reason, Know worksheet. And using this, we prepared a worksheet for each concept, and we use these to discuss concepts in detail. For example, a prioritized list of patients could look at data features such as patient condition and severity, and the system can present a ranked list to clinicians. And this exercise really helped our team formulate AI use cases in a way that is grounded in our data set. So it's scaffolded our discussions around data requirements. In the third phase, we took some of the concepts and sketched out interactions. So one of the concepts we were interested in was around mechanical ventilation. So patients who are on ventilators need to receive a breathing trial to see if they can breathe on their own. And this requires the coordinated actions of a nurse and the respiratory therapist. So the concept was, can an AI system predict the eligibility of a patient to receive a breathing trial and then present a ranked list of patients to help with coordination and patient prioritization? We conducted 4 co-design workshops with 5 nurses and 6 respiratory therapists to elicit feedback. And overall, clinicians found the concepts valuable and they shared several additional information needs. So this really helped our team to understand the design requirements for both interaction design and modeling work, especially from a user acceptance perspective. So moving forward, we see a great opportunity for HCI research to facilitate early phase AI innovation across interdisciplinary team members and stakeholders. And our work raised several open research questions for future work, such as how to analyze and select concepts in a more systematic way, or how much AI knowledge is needed for domain stakeholders to engage in ideation. Our case study suggests that systematic ideation can reveal low-risk, high-impact AI concepts, and future research should explore how this approach might generalize within and beyond healthcare to reduce AI product failures. For more information on this work, please see our full paper. Thank you.